So, what do you think this is?
An orange.
Yeah? Well, actually, believe it or not, it's an orange grapefruit. But we're going to pretend like it's the sun. Okay, so do you want to hold the sun? It's pretty hot. How hot do you think it is? The real sun?
Very hot.
Very hot, yeah. In fact, this part, the part that you see kind of like the edge of an orange, is around 6,000 degrees. That's pretty hot, right? That's 6,000 Kelvin degrees, so it's even hotter than you think. Yeah. So it's really hot. And now the sun isn't hard like this, right? The sun's made out of gas. It's like the gas in this room. In fact, it's not much denser than the gas in this room out near the edge. So if you could somehow stand to be in the heat near the edge of the sun, you just mush into it like you're walking through air. But it's really hot. And if you go inside, it gets hotter. And way down inside, it's incredibly hot. How big do you think the sun is?
10 schools high.
10 schools. That's a good guess. It's a lot bigger than that. Let's pretend like this pen, remember I was looking for this? See that little ball in the corner of it? Or in the top of it? That's why they call it a ballpoint pen. That ball, we're going to pretend is the Earth. The whole world. Okay? And actually that's too big. But we'll just pretend like that's the world. So we're making a little tiny model of the solar system. Did you ever make a model before? Like a model of airplane, or you have little toy planes or trucks or those kind of things?
I have like 4 rockets because 2 of them blew up. Actually, yeah, one did, but the other, no.
Oh, did you fly for real?
Yeah.
Neat. I'd like to do those too sometimes. Okay, so this is the Earth, and that would be the sun. The very little tiny ball in the tip is the Earth, and this is the whole sun. So the sun is huge. You could put 1,000,000 Earths inside the sun if you could figure out how to do it, right? Because the volume is 1,000,000 times that. And if this is the sun and we put it here, depending on how big my grapefruit is, that one's not very big. So if I was going to make the whole solar system, do you know what the solar system is? What is it?
Mercury, Venus, Jupiter, Mars, and Uranus, Neptune, and Pluto.
And I think we left out Saturn, maybe. But that's good. That's really good. Yeah, it's the planets and the sun, and then there's some other stuff in it, like comets and things.
Yeah.
So if we're going to make a model of the solar system, if this is the sun, the Earth would be over on the other side of the room. Okay, so it would actually be quite a ways away, maybe about 30 feet. So it would be, the solar system's mostly empty, but it's got this really big grapefruit in the middle, right? Shrinking the sun down a bunch of times. And the Earth, the whole Earth is this big, and it's way over on the other side of the room. Okay? And Jupiter would be about the size of my fingernail. Not even that big. Like a small marble, maybe. And it would be outside the building. And Pluto, I could hear, want a bunch of Plutos? Hold out your hand. Hold it out like this, like you're going to catch them. Here's lots and lots of Plutos. Pluto's so tiny, I can't even pick it up. Right? It's so tiny, that would be like tinier than a piece of dust. And it would be a mile away. Actually, about 1/3 of a mile away. A long ways. And if the universe is made out of grapefruit, that shrink the stars down to the size of grapefruit, there'd be one grapefruit here. And where do you think the next grapefruit would be to be the next nearest star? Where would you want to put it? No, way further than that. Way further than that. It would be in Florida. It would be thousands of miles, well, a little bit over 1,000 miles away. Right? So the universe, even though stars are big, the space between them is really big. Okay, so that's one thing about making, okay, now here's another thing, why I like using a grapefruit for the sun. When you look at the sun, we're going to look at it in a minute. First of all, you have to be really careful when you look at the sun. You need to have a grown-up help you, and they have to know what they're doing. Right? But we're going to look at the sun in a special way in a minute, maybe a couple of special ways. And if you look carefully, the part of the sun that we see is yellow actually looks like it has bumps on it. It doesn't really have bumps, it has bubbles of gas, right? But it looks sort of like this. They call that part the photosphere. Can you say photosphere?
Photosphere.
Yeah, it means light sphere. It's the part where the light comes from. But the inside of the sun, We don't really know absolutely for sure what the inside of the sun's like, but we think we have a pretty good idea. And so we're going to cut this grapefruit open and look at the inside of the sun. Oh, by the way, sometimes the sun has this kind of thing on it too. It's not really a sticker, it's a sunspot. Right now there aren't too many sunspots. So let's cut this in half and look at the inside of the sun. Right? So we'll cut that in half. Got to be careful with a knife. Boy, that'd be really hot, wouldn't it, if it was the real sun? If I was cutting it in half? And the real sun doesn't have any juice. It switches around. Okay, so now if we could slice the sun open, it wouldn't be the same scale as this. I'll point out what's different in a minute. But the inside is sort of broken up into these layers. You've got the layer in the middle, and then you have a layer that's kind of the parts you eat, right? You can't eat the sun. And then you have the layer on top, which is the photosphere, right? So way down inside the sun in this part is where all the energy is made. And it makes energy by, it's like having bombs go off in there. It's huge amounts of energy. Just billions of tons of matter changing to energy every second. And then above that, there's a part that looks like this, where the stuff's moving around, and it comes from deep in the sun, and comes up to the surface, and goes back down again. In fact, it makes some of these bubbles. And it also stirs up the magnetic field of the sun, and that magnetic field gets all twisted up and complicated, and it pops out through the surface, and it makes things like sunspots. And then the photosphere is not anywhere near as thick as this is relative to the size of this, but the photosphere is kind of like that. It's a layer on top of the layer that's moving. So in the real sun, this part would be bigger, the part you eat would be smaller, and the white part out here with the skin would be smaller. It would be real skinny. But same basic structure. They call it the radiative zone, the convection zone, and the photosphere. And then there's a whole bunch of the rest of the sun that sticks way out into space. It's really, really thin. It's called the corona, which just means crown. Right? So it's a part of the sun that sticks way, way out, and we can only see it with real